Okay, so here we are reviewing for our Unit D test. And so in going through this, we're going to be looking at triangles. So we're given a whole bunch of information, which is shown in this picture. And so we want to identify a right triangle. Well, we can kind of look and see where that right angle is. So it helps if we can actually draw a straight line. But I'm going to highlight this actually to show you that we could have a right angle right there. And so what triangle makes up this right angle? Well, that's triangle ABC. So that means that that is triangle ABC. But there's another triangle because there's another right angle, and we can see that here. So there's the right angle, and so that makes triangle EDC. And so those are our two right triangles. If we look going back this way, technically this is a right angle, but this is not a right, but that's not a triangle. So there's nothing we can do with that. So we're done there. Obtuse. Obtuse is going to be triangle with an angle that's larger than 90 degrees. And actually here we can show that this is going to be an obtuse angle. And the reason that's going to be obtuse is we can show that this is an acute angle. And so these two are linear pair. So that's going to be an obtuse angle. So then that gives us triangle BED, which gives us an obtuse triangle. And looking around, maybe there are some other ones. I don't think I see any. So that's going to be our obtuse triangle. Then we have scalene, where all of the sides are different. So we can see that's going to be triangle EDC, and also triangle ABC, because these are all different sides. And so that is definition of a scalene triangle. Isosceles triangles where exactly two sides are congruent. So yet again, we have that triangle BED showing these two sides being congruent. So isosceles triangle, it could be a right triangle, it could be an obtuse triangle, as is this case. So just be aware of those distinctions and how to classify these triangles. All right, so next up we have, we want to find x if the measure of each, and the measure of each side of the triangle. So triangle FGH is equilateral, meaning all sides are congruent. So here we can take any two of these sides and set them equal to each other. So I'm going to take the first side, FG, and the last side, FH, set them equal to each other. So if 2x minus 2 is going to be equal to x plus 5, this leads us to x is equal to 7. So if x is equal to 7, that means that FG is equal to 12, GH is equal to 21 minus 9, which is 12, and FH is going to be 14 minus 2, which is 12. But of course we knew that because it's equilateral. All sides are the same. LMN is isosceles, and if L is the vertex angle, that means that the other two are going to be, these two sides are going to be congruent. If you think about what this triangle looks like, if LMN is here, L is the vertex angle, LM and LN are congruent. So that means that 3x minus 2 is equal to 2x plus 1. So we get that x is equal to 3. So plugging that in, we get that LM is equal to 9 minus 2, which is 7. LN is equal to 6 plus 1, which is 7. And MN, all by its lonesome, is going to be 15 minus 2, which is 13. So that's what we need to do there. So make sure you find x and then the remaining sides. We want to classify the triangle based off its side, so that means scalene equilateral isosceles. So we need to use the distance formula. So Kp, distance here, is going to be the square root of the x's, so 2 minus the negative 3 squared, plus 1 minus 2 squared. So that is 5 squared, which is 25, plus negative 1 squared, which is 1. So Kp equals the square root of 26. We also have Kl, which is going to be the square root of negative 3 minus a negative 2 squared, plus 2 minus a negative 3 squared. So we get negative 3 minus a negative 2 is really negative 3 plus 2, so that's 1, plus 5 squared is 25. So we get that KL is equal to root 26. So we know it's no longer scalene. It's at least an isosceles triangle. But if this third side, PL, if that's the square root of 26, that means that this is an equilateral triangle. So PL is going to be 2 minus a negative 2 squared plus 1 minus a negative 3 squared. So here we get 4 squared, which is 16, plus 4 squared, which is 16. So PL is equal to the square root of 32. And so because these show two congruent sides, this is going to be isosceles. And so this is exactly the amount of work that I need to see. And so this is what we did on the quiz, what you'll do on the test, and also the midterm exam. Next up, we can do the same type of problem. So we look for Kp. Distance here is going to be 5 minus 3 squared plus negative 3 minus 4 squared. So this is going to be 2 squared, which is 4, plus negative 7 squared, which is 49. So we get that Kp is equal to the square root of 53. Next up is Kl, which is the square root of 5 minus a negative 1 squared plus negative 3 minus 1 squared. So this is going to be 6 squared, which is 36, plus negative 4 squared, which is 16. So we get that Kl is equal to the square root of 52. Close. Very, very close. And then finally, PL is going to be the square root of 3 minus a negative 1 squared plus 4 minus 1 squared. So this is the square root of 4 squared, which is 16, plus 3 squared, which is 9. And so that is the square root of 25, which is 5. So these are all different. So this is a scalene triangle. Distance formula is key. We want to find the measure of each angle for these problems. So measure of angle 1 is going to be the exterior angle theorem, because this is going to be 60 plus 80, which is 140 degrees. Measure of angle 2 is supplementary to that. So that is 180 minus 140, which is going to be 40 degrees. Now measure of angle 3 is actually going to be 105 minus 40, because that's the same as the exterior angle theorem. So that's going to be 65 degrees. Measure of angle 4 is supplementary to 105. So we subtract that from 105 to get 75 degrees. And the measure of angle 5 is going to be 75 plus 40, which is 115. So one way to do this is obviously to find all the angles inside the triangles and use, interior angles added to 180 to find these. But this is really the most straightforward. This is really quick. You can see I kind of use one angle, jump to the other, and I'm finished this in just a minute. So make sure you know that exterior angle theorem and can set up equations for these relationships. Next up, we want to find the congruent triangles. So this is going to really be an exercise in congruent parts. So here, because angle A is congruent to angle A, or angle J, we have triangle A and J. Angle B is congruent to angle K. And C to L, we got ABC is congruent to JKL. As long as these are in the same corresponding parts, then that is okay. Triangle A, so angle A and D are congruent, so A and D, angle B and angle C, and then here this is C, and this is B. Yeah, so these are just rotated around, so ABC is the same as DCB. So you can see that the C's are in different positions. That's why it's especially important that we write our angles as 3 letters, not 1, because here, angle C is this whole thing. And so some people would say, we call this angle C and this angle C, and those are not the same. So be careful with how you label. And for this one, we get parallel sides, so we know that this angle is congruent there, this angle is congruent there, and then using the third angle theorem, these angles must be congruent. So we can say that triangle J, so angle J is congruent to angle L, so JM is congruent to angle K, and then finally K is congruent to M. So just relationships there. Make sure you know how to do that. And then, of course, to prove. So here we have our proofs. And so this is going to, I think this is going to be it. Yep. So our proofs. So we got our statements. And we got our reasons. And here for the statements, we have DF bisects CDE, and CE is perpendicular to DF, and that is given. Step 2. So we're aiming for this triangle here being congruent to this triangle there. So we get that, well, what does it mean to bisect? It means that angle CDG is congruent to angle EDG, and that's definition of angle bisector or bisection. Then we also got DG is congruent to DG, and that's reflexive. And then we can also say, I'm going to combine 2 steps into one here. So I'm going to say angle CGD, CGD is congruent to angle EGD, and that's because perpendicular lines, congruent 90-degree angles. And so then we have what we want to prove. We have angle DGC is congruent to triangle, double triangle there. Triangle DGE, and the reason for that, running out of room here, is going to be angle, side, angle, and I got the angles in steps 2, the side, step 3, and 4. So these two are perpendicular, making these right angles. These angles are bisected, and this is congruent to itself, reflexive property. Should put that property. And so we have angle, side, angle. Next up, we know, oh boy, it's going to be a long proof, isn't it? We know that triangle DGC and DGE are congruent. We know that CGF and GEF are congruent. We want to prove that triangle DFC is congruent to here. All right, so the statement's one, so we're going to go with the given. So DGC is congruent to DGE. Triangle GCF is congruent to triangle GEF. That's given. And then so for step 2, we can say that side CD is congruent to side DE, and that's going to be corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Yep. 3, I can say that CF is congruent to EF, CPCTC. And then finally, I can actually say that DF is congruent to DF, and that is the reflexive property. And therefore, triangle DFC is congruent to triangle DFE, and that is side, side, side from steps 2, 3, and 4. So I actually use side, side, side here, but if you want to, you could use a whole bunch of different ways. Really, you could use the angles here to get side, angle, side. You could use the angles here to get angle, side, angle, 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 side. There's a bunch of different ways, but the key with this one was to use CPCTC. We only use that when we have congruent triangles, and we were given 2 congruent triangles. So make sure you are comfortable with the proofs. We've done tons of them, lots of answers on the website, what it means to be congruent, and how to classify these triangles. If you can do all that, then you'll be good for the test. So let me know if you have any questions.